Well. Hello. Welcome to the fifth week of ARP course. So far, we have seen the kernel of the operating system, which is the reference kernel for the POSIX standard. You have seen the concepts regarding, in particular, processes, how to run processes, how processes share resources, in particular in the user area, the open file descriptors. We have discussed the concept of file descriptor, that is the way in which we reference a file, an abstract file or a virtual file in the POSIX meaning, a file that can be a real file on disk, but in general is a stream for communication between a process, a file on hard disk, so an archive, a process with another process, a process in the network, and so on. So the concept of file, the file descriptor. We have seen how to fork a process so that two processes run being clones of the father, and the more important concept of executing a new process, which in most cases is just after a fork. So in most situations we do not execute directly a new process, but first we fork and then we execute a new process. We have seen how to make them communicate using the memory abstract file that is called pipe. That is a first in, first out buffer, and you know how to declare or to ask the system with a proper system call to have a pipe, and how to use. You have faced an exercise, and that is a true assignment. We do not evaluate this, but is the first one. And next week we will spend more of our time in programming. You will spend your time in programming. And I assume that you have finished it, if possible, the first assignment. And so let us discuss briefly this. The first assignment is interesting. I think it's a good test because it takes into account many real many concepts that you have learned. The assignment shows that we have a process P. We show. As I told you in the class, but I will repeat myself now. We can solve the exercise in many ways, but generally we use a scheme that is similar to the scheme used in thread programming. That is an initial process, the father of all processes involved in this concurrent program, forks, and continues. The first fork generates a clone P1 son, and as soon as possible P1 executes a process. A new process. The characteristic of this process is that it is an executable. So you have written, compiled, and if possible, run and tested it. We will talk a bit about this fact. In any case, executing the real process that we want to execute after forking. Let's call A. Then the process P forks again, executes P2, which is a clone of itself again, another son, and P2 executes a process B. Then there's no need to fork P again, but at the end it waits for completion of all children processes. So also P2 is a son, but they leave just the time to execute A and B, so they are substituted completely by A and B. But the important thing is that before forking, P establishes the pipes using the system call pipe. All the pipe that you need, for example, for making A and B to exchange data, and possibly P and A is just an example. Any number of pipes that are needed. So pipes are known by the P, that is that has the role of a monitor or the main controller of the execution. P usually using this scheme, so all other processes are successively forked by P and forked and executed, and P still works and is able also to talk if it is the case with well, I don't know if he's a man or a woman, it doesn't matter. In this case he's a man, you can see, and it's using standard in and standard out, so as also an interactive process, able to have commands and to control in some way also the execution of A, B, and so on and so forth. In this scheme, so this is a classical scheme. We will see and discuss in the fifth week, so next week, the opportunity of debugging separately A and B. So instead of writing and compiling the two programs and compiling P and executing all together and start debugging after they are all running, try to debug, to execute and check how they work separately as soon as possible, because I told you already, in a concurrent program composed by several processes, several computing units working pseudo-parallelism, for debugging it's the first attempt is to debug separately all processes, because it's very difficult to find an error when many processes are running together, because you don't know if it is an error coming from the algorithm, from the incorrect exchange of data, or the worst case of the timing, so synchronization, incorrect synchronization. We will see some example. You have seen an examples of non-synchronizing processes in the early example in which a process forked and used to put on the terminal window dots and bars, and how it is difficult or impossible to synchronize them in order to achieve a particular order of the output. So ordering and in execution is a key point, is a critical point, and we must test this at the end. Before that, we must be sure that A and B are good. So we will see some techniques using the same methods that we have, in particular the redirection of file descriptors, the dup primitive. This is one of the points we will see next week. Another key point that probably you have already faced it if you have tried to solve, or if you have solved the exercise I gave you, and we will briefly discuss also, is how to a process that executes a new process A, so process B is substituted completely by A, but before forking you have some, for example, pipe F, and you have a file descriptor. So A inherits those two file descriptors, but how the process A knows the numbers of the two file descriptors? Because pipe gives you back the two in this array F, two file descriptors. B can know which are the integer number distinguishing the two file descriptors, but the kernel chooses, because the kernel simply chooses the lowest integer number. There are three file descriptors, available file descriptors. Probably 0, 1, 2 are already assigned to standard in, standard out, and standard error. Or if you have closed one of them, the number can be used again, but maybe some other file descriptor are in use. So it is possible, for example, that here two numbers, I don't know, just random numbers for me, 5 and 9. So you have two file descriptors, 5 and 9. So P can access directly 5 and 9, right? 9, for example, and so on. If P wants, it's better to use directly not the number, but directly the F 1 and so on. But how? Since A did not use this system call, how A is able to know the file descriptors? How is able to know? Well, one possibility is the program is very simple, is that you have the knowledge of the file descriptor that have been assigned. For example, 0, 1, and 2 are already assigned to standard in, standard out, standard error. You know, you are sure that this is the first system call, so you are sure, reasonably sure, that the first two file descriptors that you get are 3 and 4. But this is not a good idea in general, because in other situations numbers are different. So you can, P can know which are the two values and must pass to A the file descriptors in green. Using the exec, you know, the path name and arguments. Arguments can be composed in several ways. In any case, are strings, because you know that arguments are use the same standard, use the same definition in the C language interface of the main program. So argc, argcount, and argvalue is a vector of strings, and there are several ways of passing them. The exec v, for example, from my point of view, is the simplest one, but you can prefer another one and use another one. The important thing that you pass arguments. You can pass unlimited number of arguments. In particular, you must pass the open file descriptors. You must convert the numbers into strings and put strings in the arguments as single elements of the array argv. Since exec executes a C program, so the main interface, remember that main int main arg count and argv. This is a number and this is a pointer to an array of strings. In each string the first string is the name of the executable, and the successive strings are the arguments. So this was part of this assignment. So if you have solved it, you have already solved, but it will be very interesting to discuss how you have solved. And in particular, I remember that next week, next Tuesday, some of you, for example 2 of you, more than 2 if you prefer, 1, I don't know, will show her solution and sharing the screen and showing how it works, and we will discuss all together how it works. We will do a lottery. We'll draw a number. You have a number when you join the Zoom meeting, and so it's nice, it's fun, and I show you which kind of lottery we will do. So just for fun, for computing programmers fun, let's solve the problem of selecting a random number, a random integer number, using some POSIX primitives and shell and some other pseudo files and so on. So I will show you. It's not the best and not the right way of drawing a number for a lottery, of course, but the simplest way probably is writing a C or C++ program using the rand function, which gives you a random number, and you use and normalize that to integer in the desired range, and so it's solved. But let's work on the concept we know about the in POSIX and shell, and let's do the same thing just for as an amusement. Well, you know that you have a pseudo file that is the /dev/random, and the /dev/random gives you an unlimited series of random bytes, and which it is a very good sequence of random numbers. Basically, it is the same that is used by the rand function of the C library or the rand command of the shell. But let's use it and see how to manipulate this concept in POSIX and in shell scripting. The first idea is just to output on terminal, so on standard output, the /dev/random. The cat puts the output on standard output, we can do, but the result is terrible, you see. Okay, why that? Because in unlimited sequence of random bytes, and bytes are interpreted as ASCII codes for characters, so we cannot use them. An idea could be just to put the output on a file, for example, random file, but don't do that, it's very dangerous. So let's delete the line. Very dangerous, because depending on the kernel of the parameters of your kernel and so on, this produces an unlimited in just few seconds, and a very big file that probably will fill completely the disk and block the system. So we can how to extract from this random sequence just one number. Just one number. The first byte. The first byte is a random byte, so it has a value between 0 and 255. So this is to show the concept of pipelining and of using all the commands that can be linked together using the redirection. The first element is how to get just one byte. Just one byte. There is a plenty of commands, of shell commands. There are POSIX. You see on the manual, POSIX command able to compute and transfer and change and make many kinds of elaboration of this kind. The very important in general is what is called DD, is I don't know the name, the data dump or something like that. That is accept any kind of input in terms of file descriptors and any kind of output in terms of file descriptors. And in this case you specify directly which is the file descriptor in output and file descriptor in input and in output. If you don't specify, the standard output is used instead and standard in. And you can also specify coding transformation and byte count, for example. So we want to select just to have in input as file descriptor the /dev/random. Okay, so in input this is the file, but we want just to extract only one byte. So we have some parameters in the command line, and we can specify that we want just one block. The DD has a notion of blocks of bytes, count equal to one block, and the block size is 1 byte. What is, well, there's a message that says record dentro, that means from, and fuori, out. The output is very difficult to see, but it's this strange symbol, because probably the byte has this counterpart as character. So it seems useless. Let's do it again. Well, okay, now we are lucky. So the byte was the code for small letter y. Clearly we need something else. What we can do, and we have to discard. We have to read the number instead of seeing the ASCII complement. So the simplest thing to do is just to write on a file. What we can do in several other ways, but let's use a dummy file, for example, this file, pick. Well, this is another interesting issue in shell programming and using the POSIX system. When you need a temporary file to carry out some work, you should use the /tmp directory that is a virtual file system. So tmp is not written in old systems where it was written on the disk. Now is a directory with a RAM disk, so is similar to a pipe in the sense that it uses memory, not kernel memory, user memory, but main memory instead of secondary memory, and can be used by several anyone can use that. So in this case you do the same, but you write on the on that file. So you see it did something, but now we have a file that's /tmp/pick that in which there is written just one byte, between number, an integer number, unsigned between 0 and 255. And now we use another command that is how to convert this number, or how to read the value of this number instead of outputting in the terminal window. Another typical command is od, that you can ask to convert in decimal notation. tmp pick. So now we discovered that the number was 91. Unfortunately, there are other numbers that are just the record number. 0 is the first, and 01, but no data in the second element. So we have discovered that we have the random number 91, and now we could use it for our lottery. If you are more than 91, this could be directly used. Otherwise, we have to convert into a number, a random number in the range 1 maximum number of students. Well, so this is just for fun, or just for showing you which is the way of using commands and using the shell. But now I will show you how to put all those commands in shell scripts, and also how to run two processes, synchronized processes using the shell that carry out the job. So let's have a look to this just funny exercise. The two shell scripts are pipe cyclic draw lottery and pipe cyclic selector lottery. Let's put together pipe cyclic draw in pipe with okay, that's the output and show the original random number, well, in 10 loops, so just to have more numbers. And in the first column there is the number in a range taken from assuming in the file student number, there is a number. Suppose that number of students is 42. You have to reduce the random number in the range 1 to 155 to the range 142. And this is done by this script. You see the script that the execution of those two. Let me do it again with the larger window. Okay, this is the, what does it mean? So forget for a while the effort for this such a complicated algorithm, but let's have a look to the meaning of this command and the processes hierarchy. In that case, we ask the shell to run the first executable, that is pipe cyclic draw lot. Is not an executable, is a shell script. So in this case, writing this, the shell forks and executes a new shell, executing the all the commands inside this file we will see then. Simultaneously, just after that, the main shell forks again and executes a new shell, another shell, executing this second script. And before executing the two sub-shells, shell number 1, shell number 2, it redirects the standard output of the first shell into the standard input of the second shell using the DAP, closed DAP system calls, so that they act as filters. The idea of filters, and the name pipe evokes exactly the idea of a tube connecting the two filters. So this draws a number. It's a 10 steps cycle, and all numbers are taken in input by the second script, the second shell, that is executing other commands, able to make the normalization considering the maximum number of students. So, and this is the output. How are the two scripts? Just have a look, and I will put in any case in our web just to have an idea of how the execution fork exec and redirection is the core mechanism in POSIX subsumed by the shell. So let's see the first one, for example, how to draw a number, similar to the command we have seen before, just a bit richer, less pipe cycle draw lot. This is the script. There is a loop in shell syntax, so is a while loop with a counter that increments from 1 to 11, and so it does it 10 times. The first is the DD we have already seen, with some slight changes. This says minimize the additional information in output, so do not disturb the output, those numbers, record number and so on, and put the all standard output messages on the /def/null, just to erase. You remember that is a null driver, so you can write everything and is completely erased, not considered. After doing that, so it writes on the /tmp/pig file. Then it's a successive command. The OD converts the number in the byte in number in pipe. So as a matter of fact, here the pipe, the subshell, the shell executing this, forks and executes the command, the sed, that is a way of editing the output, and connecting the output of the OD to the input of SED, then forking again and executing an additional SED. This is just to erase the unuseful strings, the 00 strings and the 001, and then forks third time just to erase also the new line, so that just to have a pure number in output. So you see that several processes are involved in this. Not needed. I told you, it's just for fun. It's just for having a complex solution using all possibilities, all complex possibilities, but very simple from the computational point of view of the shell. And let's see the second script. The second script is able just to read the number and simply does arithmetical computation, and it shows also the fact that the shell is absolutely powerful in managing file descriptors, channel communication, executable files, and anything, but is very weak in making numerical computation. So this is, you see that just for normalizing the number that is in the range 0 to 155 and 55 to the range 1 max number of students that is read in this variable. This reads in the variable m the number inside that file, and so the expression is a bit complex, so it is not simple to. The shell is not for executing numerical computation. We have commands for doing that. And then at last we have the computed number, that is x, and to print out a shell variable we must prefix the $sign, because all shell variables are taken in the shell as strings, and this is the idea, is just print out the string with the computed value and the original value, and so on. And this is just to make the counter of the. So very complex solution for a very simple problem, but the aim was just to use many features of POSIX, of the file system, of the shell itself. So we are 6 processes involved for computing this, instead of just writing a 10 lines C code. But I think it's a good way of exercising your knowledge about the processes and shell and so on, if you want. I will put also this solution with a disclaimer that says don't do that. It's not necessary to do that. It's just for showing how to use the POSIX primitives. So one more thing, just the last one. This week you will use all the concepts you've learned, and you will use in programming and develop new programs. I will give you more time to work in small groups with the same idea, just to design the solutions all together and to carry home the work you did in groups, and to develop at home individually your solution. So next week you will be able to show using the lottery and to discuss, just to prepare ourselves to the real assignment in the week after. We'll anticipate that the next week, even if in the faculty there's a break in classes due to the graduation, on Wednesday we will have the class. I will, in any case, since there are no robotics engineering graduation, and I will put the notice in our web, and you will know everyone. Just a preview of the concept we will start to discuss next week. In any case, is the concept of determinism. Let me take the table. Okay. Suppose we have, and so go back in your memory to the general framework in communication between modules or process or tasks in distributed systems. Suppose that we have two data producer, P1 and P2, more than two. It doesn't matter, even one. Just an example. This is related to the concept of publish subscribe. That is an important paradigm of communication. Suppose we have one consumer and data consumer. So this produces, and we know that the way of doing that so far, as we know, is using pipes. So suppose that as in many automation and robotics in particular, robotic application, all these processes are cyclic in the sense that they never end except for some emergency situation or for some fault. So with the timing that we don't know, so in time P1 can produce data this way, and for hours no other data. P2 may have a completely different scheme of generating data, so may generate continuous data, but sometimes it may rest. P3 is maybe emergency process, so that it produces data very rarely or never. How the process C can receive data from all this, of the three processes here using pipes? Remember that pipes are blocking channels. Well, not pipes. Read is blocking. Any read in POSIX is blocking. Is a blocking primitive. Blocking in the sense that if there is not here, if there is nothing to read, if there is nothing to read in this pipe, C, while attempts to read from that pipe, waits until a new value can be read. There's no way of overcoming this. So blocking is a problem, since C cannot be desynchronized from P1, P2, and P3. Desync. So it must necessarily be synchronized to generation of data by P1, P2, and P3 in some way. If we trust in the fact that P1, P2, and P3 generate data, okay, we go. But it's not a general assumption. So we must absolutely desynchronize C. So we must find out some primitive to avoid that you block while reading data. Probably in most situations you are blocked, so you accept to be blocked because you assume that P1, P2 and P3 generate data, and you must not wait too much. But in general, you must deblock or desync. How to do that? Well, this is an additional POSIX primitive. That is not a new primitive, a new communication primitive. You cannot find a non-blocking pipe. Pipes, since they are used by write and read. Oh, well, also P1 can be blocked while trying to write on this pipe. If C does not empty the pipe, when the pipe is full, P1 is blocked. So even if the more dramatic situation from the consumer side, also from the producer side, there is the same symmetrical situation. You have to deblock. We will see an important, an absolutely important primitive, and we will not use this week, next week, but we will start discussing it and how to to do that. And how does it work? In the simplest way, because we are in POSIX, and in POSIX we are at the lowest possible level of standard and implementation of principles. The lowest level is to look before read. So it's a simple principle. So you don't have a new read that is not blocking. You before reading, you can, if you want, if you need that, you can look if there are data to be read. In that case, you can choose the pipe and that has data, or if no pipe has data to be read, you just wait for the first pipe with data. But in any case, you never try to write data from a pipe that you know in advance that is empty. This is a very important principle, and in theoretical concurrent programming is called, well, whatever. Want a new color? I don't have a new color. Black. Non-determinism. Even if non-determinism may seem something a drawback or something lack of something, is a powerful principle that says that you not necessarily is not determined the first action that in a concurrent process must do. Is not determined by the structure of the software, in particular the communication input-output. And even it can be also a random execution. For example, if two pipes have data, the third one has no data, you toss a coin and decide which one to read first. So non-determinism is at the same time a principle in which causality can be introduced and taken into account and managed by your algorithm, and you're not blocked by a deterministic order of a sequence of execution. So this is a theoretical principle, and those who learn theoretical computer science in concurrent programming know well that is a really absolutely mandatory concept. We will face, from a pragmatic point of view, learning how to implement algorithm with this issue. Okay, Thank you very much. See you next week. See you soon. Prepare your solution for the last assignment. I hope that some of you will describe a good solution. Bye. Thank you very much.